Hello everyone, my name is Aslanyan. I'm a principal of NAFTA College, and today I would like to talk about the digital assets in petroleum industry, but in a bigger picture. What I'm going to talk about is the digital twins, digital assistants, and digital consultants. Those are the three, I would say, staples of the digitalization era, which in its turn is a kind of a core of the fourth industrial revolution. Those terms like digital twins, digital assistants, digital consultants, they become quite common today. Many people understand different things under these terms. And I think that the industry is trying to find a way how to come up to the terms. What we are doing today in different areas of this industry, particularly in petroleum industry, we are trying to find our own way. How do we see the digital twins? How do we see the digital assistants and the digital consultants? I would say that this process is just starting. We are not even close to the midway. What will come after, it's difficult to predict. But what I'm trying to do today is to show the exercises, specifically what NAFTA College is enterprising in this area. And we will be talking about specifically the Petroleum Asset Simulator. As you know, probably that the petroleum industry is something which where the people are trying to recover the minerals and the fluids like oil and gas from subsurface. So the subsurface, the geology where these reserves stay is a core element of the petroleum industry. And when you run the business around recovering the reserves, you obviously drill the wells, you obviously set up the surface infrastructure, so you run the economics. It's a big business. It's an important business for the whole world. The energy resources is the foundation of any other industry in our life. So basically the importance of that is really high. And not surprised that we see a lot of the efforts in digitalization and automation investments into this area. And the digital twin as a mirror or something which happens in real life become a kind of a challenge for the petroleum industry to come up with. And we see a lot of the digital twins in different areas, like digital twin of the drilling, digital twin of the pipeline systems. But what we're going to discuss today is the digital twin of the integrated business process, which includes the recovery of the reserves, transportation, and all the way up to the economics. And that's what we call a petroleum asset digital twin. So as you can see from that picture, the picture to the left shows you a kind of a screenshot of what happens in real life, whereas to the left you see a person which is sitting across the computer monitor and watch the representation or a mirror of what happens in real life. And that's what we call a digital twin. And what are the components of the digital twin? The software, the pieces of the software which we have to build in order to create that integrated facility. And the first component obviously is the geological model of the reserves, how they have been created, matured, and located in that place. And then we go to the dynamic flow model, because if you want to recover these reserves, you have to force the fluid to flow from the pore area into the wells. And then you go to the well model. You have to model the way the fluid moves through the well, whether it's up from the subsurface to the surface, or sometimes the petroleum engineering, they do the injection of the gas and water back into the reservoir. And the next one is the surface facilities, which are obviously, as it suggests by its name, they stay on the surface and they transport the fluids, water, oil, and gas towards the processing plants. And when you run that business, in petroleum industry, you have to start retrieving the data about the rocks, about the wells, about the surface facilities. You definitely go for the surveillance. And one of the key surveillance in petroleum industry is the open hole log analysis, and that component should be put into the computer space as well. And once you already have the wells, and you understand to some extent, you understand the rocks, you have to start understanding the performance of the well itself. The wells, just like people, they tend to be misbehaving. They have some issues, they have integrity issues, they have performance issues, and you have to run the surveillance to understand what's going on with this well. And that has to become a part of the digital asset as well. So that caused a case hole log analysis. The other popular surveillance in petroleum industry is the pressure and rate transient analysis, where the people analyze how the production is changing over time and how does it relate to the changes of the pressure over the time. So those two, they constitute what is called a pressure rate transient analysis, a very important surveillance mechanism to understand the reservoir and well behavior. The other component of any digital twin, not only the petroleum assets, but basically any digital twin, which at least those who try to mirror the business processes, is the economics, which includes the ins and outs. And we're going to talk about this a little bit later. The other component of the digital twins is consolidated statistics. So the robots today, they keep tracking on what's going on, and they bring the numbers to the screen so that people can analyze these numbers and understand what's going on. And this kind of the statistics of monitoring normally split into the two categories. One is the consolidated, just the numbers, and the other one is something which has a visual representation, like graphs or the maps, and that one we call the activity by activity analysis. So those components, they are constituent parts of the digital twin. Now let's go see very briefly, by the way, what's inside. Well, definitely, we don't have enough time to go into the foundations of the petroleum engineering. That's going to take hours, if not days, if not weeks. But what we're going to do here is we're going to show you the pictures. What are the pictures, the images which are associated with the components which I just previously described? So when you say geological model, we normally see the cross sections of the different stratums, subsurface. We see the maps. That's what we say the geological model is. The other one is the dynamic flow model, and what we see is the streamlines of fluid, which is moving from one areas of the 3D reservoir towards the wells, or away from the wells if this is an injecting well. And the other one is the well model. What is the picture associated with the well model? It's kind of the pipe which is going, a hole in the ground and a pipe within the hole, and we can see that there is a perforation which connects the well with the reservoir, and we can see the fluids. Well, in this particular case, it's pictured like bubbles. They're moving either from the reservoir through the perforations into the well and then lifting up, or they are moving down because we pump them from the surface and want them to get into the reservoir. The other one is the surface facility model, and when we talk about the surface facility model, it's easier to comprehend for the majority of people. It's like a small plant. Well, yeah, I cannot say small, it's quite big actually, but it's basically spread of the area. So each of the components of the surface facilities in the conventional oil and gas field, they are not really huge, like the downstream processing plants, for example, but they are a lot, and they are distributed over the large areas. They are connected by the plant, by the pipes. There are some plants, the processing plants. There are pipes, chokes, valves, and every single thing is being modeled and put into the computer space. So creating a kind of a butterfly effect. When you actually choke down, you can actually change the choke size in just one node of that surface facility. And then it will change everything, the flow from the particular well or the group of wells, and it will impact the economics. Everything will be calculated in the computer space automatically and very quickly, by the way. And the next one is the open hole simulator. When we say open hole simulator, we mean that the well was drilled. The petroleum engineers, they put the tools, the modern tools are, open hole tools are the kind of computers with a lot of sensors which try to sense what's going on in reservoir, what its porosity, permeability, what type of the fluid it is in. And normally, this is the picture we see on the screen when we talk about the open hole simulations. Behind every single sensor, there is a high-class mathematics. If you look at the right, you can see the samples of the core, which have been retrieved from the well during the drilling. And what you can see is that the core, it looks like a stone, but that stone has a mineral compound, and the fluid, and it has porous space in it. And that porous space is filled with fluids, and the fluids have the chemical compounds. So it's a great challenge for petroleum engineers to pull down the tool full of sensors. I mean, we're talking about the dozens of sensors. And that sensors, they do everything they can do. They emit nutrients, they capture the gammas, they check the temperature, the pressure, the acoustics, electrical resistivity, magnetic response. They try to do everything what physics knows in order to understand the behavior of the rocks, to characterize the rocks, and to make a match of the sensors to the cores which have been retrieved and studied in laboratory. So everything what you just said is being modeled and put into the digital twin. The next one is the case hole simulator. That's already a live episode of the well when it's been completed, and the steel pipes have been pulled down, so you don't have a direct access to the reservoir and rocks anymore. But what you want to understand is the performance of the rocks behind the well, the steel wells, and that uses different types of the physics and sensors to do that. And you want to understand the integrity of that, we call it a completion. Actually, the well, the modern wells are not just their hole in the ground. If you look down through the pipe, which are many kilometers, by the way, sometimes horizontalized, inside of that well, it's a whole building. They have so many steel and rubber and plastic facilities in it, all type of the materials you can find, ceramics. It's a very complicated structure inside of that hole. So basically, it needs to be monitored and assessed and understand if it works properly. So everything is being simulated in the digital twin. And then we go for the pressure and transient analysis simulation. It's probably one of the earliest way of the surveying and understanding the rocks and the well behavior, the contact between the well and the rocks. Normally we see the picture like this, logarithmic, dual logarithmic plots, understanding the pressure against the flow rate changes has been also put into the digital twin. And obviously the economics, which, as I said before, split into two halves. One is that what we put as the input to the economics, obviously the price of the fluids which we recover and sell, the costs associated with running the business, the flat costs, the operational costs, the capital cost, everything, the taxes, all kind of the expenses which normally you find in the financial statements, they all put into the professional, as the input into the professional financial model. And the other one is the economics output data. That's probably a biggest concern for the investors or the top managers of the company who make a decision to invest cash into the development of the facility. Probably drill more wells, do the walkovers, build up or upgrade the current facilities, or sometimes just to sell the asset to someone else. And that needs another type of the economic study. It's called the investment modeling. And the digital twins, which we run in NAFT College, we put all of this, if not all, but at least the majority of the popular investment metrics into the digital twin, including the NPV, profitability index with the account of the discount rate, with the return on investments, the IRRs, the modified IRRs. There's a large large set of the investment metrics, which the majority of the investment and financial people understand, in order to make a proper decision on which way to go. And as we say, consolidated activity statistics, we normally have association with a table, the one you just see to the right of me. And that table is basically shows you the rows with the metrics and the columns, which represent various scenarios, what can be done with that field. And based on these numbers, you can assess the technology performance, the technological performance of some scenarios. So before they go to the economics, we have to assure that from the technological point of view, we've made the best job. And that consolidated activity statistics help to understand the strategy. If your strategy of the scenarios in the columns is good or bad, in which component in the rows, one scenario is better than the other. That table helps us to pick up the best technology scenario or a short set of the technology scenarios which we'll be sending to the economical department to make the final decision on the best economics. And the activity by activity analysis. Sometimes the strategy can be, the strategies of the two scenarios could be quite close, but still the performance can be very different, even if the strategy is similar. And that, in this case, we have to acknowledge that the asset, the real asset and its digital twin are really complex. They are highly complex, and we cannot come up with the ultimate scenario without looking into the inhomogeneities of how reserve is distributed. In this case, we have to scrutinize every scenario with activity by activity analysis. And that's how the digital twin is creating the pictures. You can see them to the right. You can see the typical pictures of the activity by activity analysis, which help people to understand or refine the scenario. Now we go from, I think we finished with the digital twins, and the next chapter is the digital assistants. What do we understand by the digital assistant? First of all, the border between the digital twins and digital assistant is not so clear. Basically, if we come back to the few slides before, like activity by activity analysis and the consolidated activity analysis, this kind of the output from the digital twin can be already considered as the digital assistants, because they assist us in computing these numbers or the pictures or the graphs and bringing them onto the screen. Well, yet the digital assistants today is a little bit more than just building the metrics. And many digital assistants today, they have AI components, artificial intelligence components. So they are not only building the numbers or borrow the numbers which have been built by the digital twin. They also provide the automated analysis of this data, and they come up with the vision of the robotized vision of what's going on with reserves, with the well, with the facilities. They do not provide recommendations, but they really assist in understanding of the performance and the status of the reserves. Normally in real life, when a real petroleum engineer is using the digital assistant, it's relying on its advisors. But the ultimate decision on the analysis of what they are going is made by a human, because sometimes the human, and not sometimes, quite often, they factor in a lot of the non-systematic factors which the digital assistants cannot take in. So basically, it's not like the people are smarter than digital assistants, which, by the way, they are. But the point is that sometimes people have more information which, when they comparing to the digital assistants, current version of the digital assistant, which can only take that number of information, and he doesn't understand any extra information. So the digital assistant is an important component of the digitalization era, and as I told you, it not only computes the numbers and some maps and graphs, but it also analyzes them. So if we go to I just want to tell you about the three particular digital assistants which we implemented in our digital facility, which is the field and well production analysis, dynamic data analysis, and field development planning. So if you go to the field production analysis, those are the pictures which are normally associated with understanding of the status of the reserves, layer by layer, the performance, the integral performance, and the automated responses, the automated suggestions from the digital assistants on what possibly happens here. Do we have the thief water production? Do we have thief water injection? Do we have an homogeneous performance? Is it matching the expectations which we have from the project, field development, master development project, or it exceeds expectations or goes beyond the schedule? That's kind of a things which we normally expect from the digital assistant to do. The next one is the well production analysis. In this case, we focus on single well, well by well, and we try to understand the performance of that well. Does it perform properly as expected? Are there any integrity issues? Is there any hidden potential which was not revealed in the beginning when we thought, where we understood that well and we modeled that well, but based on its exceedingly good performance, we see that we overlooked a performance of that. We overlooked the amount of the reserves, of the energy of the reserves around that well, and we can come back and amend it. So the next one is the dynamic data analysis. That's another important digital assistant. We've been talking about before about the rate transient analysis and pressure transient analysis. Those are the facilities which simulate, but this facility, it analyzes the results of the simulations, comparison against the expectation, and come up with the advices of what is the potential on the cross-well connectivity or the drainage area around the well, which is an important, or the well performance itself. Those are very important analyses which are normally done by people. They need a lot of training. So basically all the training we have today in the past, 70 years, they currently are being put into the artificial intelligence to help us at least to pick up the obvious misperformances or obvious potentials. So the amounts of the effort the analyst has to put into the, I would say, manual processing today or manual analysis becomes really, really less comparing to what has been done even 10, 20 years ago. And of course, the field development planning. The field development planning assistant is a smart guy, is a smart robot which analyzes which trying to do a lot of the scenarios in its computer head. It's trying to drill the wells, it's trying to do the walkovers, it's trying to upgrade the facilities, it's trying to do many things which we as reservoir engineers understand can be done and should be tried out. So it's trying out in his computer space. And because it's really fast thinking guy, he can do a lot of the exercises and then come up with the investment metrics, just like in this picture. So a human which is running that facility, he can look at these graphs, he can see either a perfect solution when all financial metrics meet at one point, or at least they can see a kind of a short list of the opportunities which that digital assistant help him to zoom on. Well, I think I covered enough the digital assistants. And the next question is, what is the digital consultant? And that term recently appeared as something different from the digital assistant. And I totally agree with that, because the digital consultant is not just the assistant in the analysis, but that's another smart guy who analyzes the results of the digital assistants, which are based on the digital twins, and the digital consultant trying to come up with the recommendations, with the suggestions. So basically, it's like a human. It's like a GPT bot across you. So when you talk to the digital consultant, you actually ask him questions. We also call them bots. So you ask questions to the bots. What do you think is going on? What do you think is the strategic problems of that particular asset? Which particular scenarios you think is the best to carry on? And that digital consultant is answering you in textual form. It can send you the digital pictures as well. And you actually converse with him. You can actually deviate from what he says. You can actually tell that you disagree with him, or you can ask him to take into account the information which probably you believe he overlooked. He or she or it doesn't matter, that's a bot. You know, and the bot today can have any face. It could be a woman face, a man face, it could be a robot face. It's up to you. So basically, it's the brain thing which is important in this particular case. So, and if we have a bot, if we manage to create a bot which is of value to a human, it helps a human to analyze the assets, the petroleum asset, and come up with the investment scenarios. The next question is, how can we ensure that this bot is the best? What if someone comes with another bot which is better than the previous one? And it's absolutely true. So many people around, so many experts across the world, they can come up with the different methodologies, how to analyze, how to arrive from the analysis to the decisions. And as many reservoir engineers, talented reservoir engineers we have across the world, as many boats we're going to have in the future. And those boats will be competing against each other. And the question is how to understand which bot is better. And I believe that the best way to compare the efficiency of the bots is to put them on the competing on robotized platform, like for example the Petrocup platform. Today the Petrocup platform is basically not looking. The Petrocup platform is assembling the teams, the petroleum asset teams, 10-15 people each, where the multidisciplinary teams of people trying to compete against each other, whoever can develop the field better than the other team. And the net result is the financial performance of the team, and all the processes are robotized. So basically this is a absolutely adequate platform to see how the bots competing against and rank the bots and help them to grow. If the bot is losing the game, a competition to another bot, then probably has to look at the consolidated activity statistics into the AAA activity by activity statistics, understands where exactly it loses to another bot and improve it. And that will be a grand battle of the bots as we see it in future. With this in mind, I just want to tell you thank you very much. I believe I was trying to be as short as possible to give you a very high picture of the digitalization era of the fourth industrial revolution and those concepts of the digital twin, of the digital assistant and the digital consultants, at least within the frame of the petroleum asset. I tried to show that to you as much as I understand them now today. Thank you very much and see you next time.